So good morning everyone. Today we will discuss about collision concept. What is collision? When two bodies exert a large amount of force over each other for a very small interval of time. Means the force on first due to second and the force on second due to first. Let me write it for you. F21 vector and F12 vector. They are exerting large force F21 or F12. They are large forces, greater forces exerted on two bodies with respect to each other in very small interval of time. That kind of event is called collision. When two bodies exert large amount of force in a very amount of time or a small interval of time, that phenomena is called collision. This is the basic definition of collision. Now, if we talk about the basic properties related to collision, so we know it very well. When two bodies collide with each other, they exert equal and opposite forces. Means F12 vector, if I talk about in vector form, F12 vector equals to minus F21 vector according to action reaction law. So they are obeying the laws of motion. Second thing is that the total momentum of the system will remain conserved still. They will follow the law of conservation of momentum. Means the total momentum of the system will remain conserved during any kind of collision. Total momentum is conserved. If I talk about total energy of the system, it will remain conserved. Total energy is also conserved. But if we specifically talk about kinetic energy of the system, kinetic energy, and here comes the difference, or here comes the types of collision. So there are total three types of collision. There are total three types, and all these three types will have these two common properties. Means total momentum will remain same, total energy will remain same. But if we talk about kinetic energy of the system, total kinetic energy of the system, so please pay attention. There are three types. One is elastic collision, second is inelastic collision, and the third is super elastic collision. And these types of collisions can be explained on the basis of kinetic energy. If I talk about total kinetic energy of the system, total kinetic energy of the system. So for elastic collision, there will be no change in the total kinetic energy of the system. Means the total kinetic energy of the system will remain conserved. It will remain conserved or constant. There is no change, no loss, no gain. That is total kinetic energy of the system. It will remain conserved. So that kind of a collision is called elastic collision. Means that kind of collision in which there will be no change in the total kinetic energy of the system. So you will say that kind of collision is elastic collision. If there is a loss in kinetic energy, if there is a loss in total kinetic energy of the system, it means this is a type of inelastic collision. And if there is a gain in total kinetic energy, it means it will be super elastic collision. So it will be easier for you to define three types of collisions on the basis of total kinetic energy. While these two properties will remain same for any type of collision, elastic, inelastic or super elastic. Keep this thing in your mind. So first target is elastic collision in one dimension. So let's assume two bodies are moving in the same direction. Let's say body first of mass m1, body second of mass m2. Its initial velocity is supposed to be u1 and u2. Keep this thing in mind. Why I'm taking in the same direction? Because we do not need to take care of the sign convention. Otherwise, if you are moving it towards first body, so you have to take minus u2. So it would be easier for you to understand this way. Now, if u1 is greater than u2, so definitely the first ball will collide with the second ball. So this is the collision, and during the collision, according to action reaction law, they will exert equal and opposite forces over each other, action and reaction. So first the force of first on the second, or you can say force on second due to the first F21 vector, and the same the reaction force on first due to second F12 vector, according to action reaction law. These are equal and opposite forces clearly. And this is a situation before collision. You will write it completely. This is a situation before collision, the collision, and after the collision. Definitely, the first ball is experiencing an opposite force. So definitely there will be a retardation in the first ball. So first ball's velocity will get changed. The first ball's new velocity is supposed to be v1, and v1 is actually less than u1. v1 is less than u1. You know why? Because there is a retardation. So v1 is less than u1. Keep this thing in your mind. In the same way, if we talk about the second ball is having the force in the direction of its motion. So it will get accelerated. Positive acceleration will be there, which means second ball's velocity will change u2 to v2, and v2 would be greater than u2 clearly. So this is the condition after collision. And now, if we apply law of conservation of momentum, we know it very well, the law of conservation of momentum. So from law of conservation of momentum, you will write it completely. Law of conservation of momentum is total momentum before collision equals to total momentum after collision. In the laws of motion chapter, we had discussed about this. Law of conservation of momentum. Total momentum before collision equals to total momentum after collision, which means total momentum before collision m1 u1 plus m2 u2. Momentum is mass into velocity. So total momentum before collision m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2 after collision. This is the total momentum before collision and total momentum after collision. Let's take the information for first body on left side and information for second body on the right side. So you will get m1 u1 minus m1 v1 equals to m2 v2 minus m2 u2. Now take m1 minus m1 common from this side and m2 from that side. You can use it. Minus m1, or you can, if you want to take simply m1 common, so you can write like this. It's your choice completely. m1, you can write u1 minus v1 equals to m2 v2 minus u2. Keep this in your mind. Let's say equation first. This is our conclusion for equation first. Now, if we are talking about elastic collision, we are talking about elastic collisions, which means the total kinetic energy of the system remains conserved. We know it very well. For elastic collision, whatever it is, one dimension or two dimension, it doesn't matter at all. It should follow the actual scenario, and the actual the meaning of elastic collision is total kinetic energy will remain same. Total kinetic energy before collision would be equal to total kinetic energy after collision. You will write it completely. Total kinetic energy before collision equals to total kinetic energy after collision. So total kinetic energy before collision of the whole system. So kinetic energy formula is half mv square. So total kinetic energy before collision half m1 u1 square plus half m2 u2 square before collision, and after collision half m1 v1 square plus half m2 v2 square, and half can be cancelled out by taking common. So you will get m1 u1 square plus m2 u2 square, m1 v1 square plus m2 v2 square. So take one information for first body on left side and information for second body on the right side. So you will get this expression m1 u1 square minus m1 v1 square equals to m2 v2 square minus m2 u2 square. This one. And now you can do one thing, that take m1 common and open a square minus b square formula. So take m1 common and open a square minus b square. So u1 square minus v1 square, it would be u1 minus v1 and u1 plus v1. So m1 into u1 minus v1 and u1 plus v1. Keep this thing in your mind. u1 plus v1 equals to Same process will be there. M2 common. So V2 square minus U2 square. So V2 minus U2 and V2 plus U2. So M2 common, V2 minus U2 and V2 plus U2. This one you can take. Now please pay attention on the highlighted part. M1 into U1 minus V1 and M2 into V2 minus U2. They are just same from equation first. Please pay attention on this. From equation first, they are just same. You can see M1 U1 minus V1 equals to M2 V2 minus U2. If they are same, they can be cancelled. So this whole term, they will get cancelled. So you will get the output as U1 plus V1 equals to V2 plus U2. Take U information on one side and V information on the other side. So you will get U1 minus U2 equals to V2 minus V1. This one. And if you pay attention, U1 is the initial velocity of the first body. U2 is the initial velocity of the second body. So U1 minus U2 is telling about the relative velocity of first with respect to second. When they are in the same direction, the relative motion. Like a bus is crossing another, overtaking another bus, the relative velocity. So for the same direction, non-contact relative motion, they will subtract. So U1 minus U2 is telling you about the relative motion before collision, and V2 minus V1 is telling you about the relative motion after collision. So this is the conclusion which you need to pay attention. The relative motion before collision, it will remain equal to relative motion or relative velocity. You can say relative motion or relative velocity before collision. It will be same as relative motion or velocity, relative motion or velocity after collision. Means if we are talking about elastic collision, so there will be no change in relative velocities of the body. If two bodies are colliding elastically, then there will be no change in their relative motion. This is the final conclusion for elastic collision in one dimension. Even for two dimension, only one change you will have to make to break down the components of two-dimensional motion. But still conclusion will remain same. So if we talk about inelastic collision one dimension, so definitely there will be a loss in kinetic energy. To make this sure, let's say the first body in the first case means the before collision, the second body is actually at rest. Means its U2 is 0. The second body initially at rest. U2 is 0, and after collision, these two bodies stick together and they start to move together in a particular direction. After the collision, they are moving together, and you can take another case that they are moving with different velocities like earlier. So it's your choice completely. There are two cases. You can go for that thing in according to your book also, and it would be easier if they are moving with different velocities after collision. So this time they stick together, M1 and M2, and they are moving in the same direction with the common velocity V. So for this situation, we need to calculate what will be the loss in kinetic energy, because if this is inelastic collision, then definitely there will be a loss in kinetic energy, and we will prove it. Keep this thing in mind. We will prove that this is a kind of inelastic collision. So let's first again implement law of conservation of momentum. Total momentum before collision equals to total momentum after collision. M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2, but V1 and V2 are same, that is V, common velocity. So I am writing it V simply. And U2 is actually 0 because second ball is initially at rest. So U2 term will get terminated here. So you can calculate V from this expression. So V, you can conclude that M1 plus M2 into V common equals to M1 U1, only M1 U1, because U2 is 0. So you can calculate the value of V. V is M1 U1 upon M1 plus M2. This is the outcome for common velocity by which these two balls are moving. This is the velocity, and definitely it can't be 0. You know why? Because it can be 0 only when U1 is 0, and since U1 is if U1 is 0, it means that they are not moving at all. So there is no purpose to study about this topic. So obviously, if we are talking about the collision, so the first ball should move at least. And if u1 is non-zero, so v can't be zero. So keep this in your mind. V will remain non-zero value. Now let's talk about loss in kinetic energy. So for inelastic collision, definitely there will be a loss in kinetic energy, and we will prove it. So loss in kinetic energy of the system. So total kinetic and loss, how can we calculate loss? Total kinetic energy before and total kinetic energy after collision. When we talk about loss, so initial data would be greater than the final data because we are talking about loss. So it will be calculated by total kinetic energy before collision minus total kinetic energy after collision. So let's calculate. That is called loss in kinetic energy and can be represented by delta Ke. So delta Ke, so loss in kinetic energy is total kinetic energy before collision, half m1 u1 square plus half m2 u2 square. But u2 is 0, so clearly half m1 u1 square only, since u2 is 0. Keep this in your mind. Minus total kinetic energy after collision. After collision, velocity is v, mass is m1 plus m2. So half m1 plus m2 into v square. Now you will be able to place the value of v. V is m1 u1 upon m1 plus m2. Let's say equation first. So from equation first, we can place the value of v. So what will be the conclusion? Half you can take common out. So half common, and m1 u1 square minus m1 plus m2 into v square. It is v square, not only v. Keep this in mind. It is v square. So v square means m1 square u1 square upon m1 plus m2 whole square. M1 plus m2 whole square. This is, now you can see that there is m1 plus m2 whole square and this is m1 plus m2 single power. So one power will get cancelled. So the final conclusion is change or loss in kinetic energy delta Ke equals to, now please pay attention, m1 is there, u1 square is there, m1 is there, one term, u1 square is there, you can take it out common. So m1 u1 square common upon 2 into, I am writing it here, into this one, into, now you have taken m1 u1 square common, so it will become 1 minus this one, only m1 will remain, m1 single power upon 1 m1 plus m2 power has been cancelled, so m1 plus m2, bracket close. Now after taking LCM, m1 plus m2 as a LCM, so upper term it will become m1 plus m2 minus m1, so m1 to m1 will get cancelled, so loss in kinetic energy equals to m1 u1 square upon 2 into, here m1 plus m2 minus m1 to m1 cancels, so only m2 upon m1 plus m2, this one. Or you can write it completely that loss in kinetic energy equals to m1 m2 into u1 square upon m1 plus m2. And we know it very well that if collision is there, it means the first body must be in motion, and if the first body is in motion, so u1 can't be 0 and neither m1 nor m2 can't, they will be 0. No one, because mass must exist. So m1 is non-zero value, m2 is a non-zero value, u1 is a non-zero, so definitely delta K will be a non-zero, means definitely there will be a loss in kinetic energy, means it is an inelastic collision. So there is a justification for the condition and the loss in kinetic energy for inelastic collision. When we talk about elastic collision in two dimensions, so before colliding, these two bodies, they are actually moving in the same direction. You can say these two bodies are moving in the same direction. Means first body with u1 velocity, second body with u2 velocity, mass m2, mass m1. But after the collision, they collide with each other by exerting equal and opposite forces, f12 vector, or you can write f21 vector, and force on first due to second, f12 vector. And after that, now here comes the outcome, that this time, if I say this is the horizontal line, that x dash, this time suppose the first ball is going in this direction by making an angle theta, let's say theta angle. In this direction, the first ball is going. This one, the shaded one, is the first ball. The first ball is going in this direction with velocity v1, and the second ball after collision is going in another direction. Means we are talking about this time xy plane. You need to pay attention. This time we are talking about xy plane, y dash. It is they are moving in the xy plane. So second ball, it is moving m1, and this one is m2. Let's say this is the first ball, shaded one. It will be easier for you to understand. So second ball is moving in this direction. By not necessarily they will make the same angle. No, it is not necessary. So let's say second ball is moving with an angle of phi. It is moving with an angle of phi in the second dimension. We can say xy plane in the other direction with velocity v2 after collision. Now here comes the problem that you can't apply law of conservation of momentum or the kinetic. We can say vector quantity directly. So you have to go for resolution of vector for two different directions. So you have to resolve the components. So v1 will have two components. One in x. So v1 cos theta. We can say v1 cos theta, the horizontal component, and the vertical component would be v1 sin theta. v1 sin theta. That will be the components of first ball velocity, and the components of second ball velocity. One will lie along this, that is v2 cos phi, and the second will be against the first vertical component, that is v2 sin phi. So if you are taking this data as positive, you have to take this data as negative. Keep this thing in mind. This data as negative because it is lying in negative opposite direction, and they are lying in the same direction. So they will be positive for both. So you will have to study the law of conservation of momentum in x-axis separated and in y-axis separately. That will be the conclusion, and it will be so easy for you to study in that case. So law of conservation of momentum in x-axis, total momentum before and total momentum after. So before they are truly moving in the x-axis. So m1 u1 plus m2 u2 before, and after this time, after collision, total momentum we are talking about in x-axis. Keep this in your mind. So m1 v1 cos theta, m1 v1 cos theta plus m2 v2 cos theta, m2 v2 cos theta. This one will be the expression for law of conservation of momentum in x-axis. In the same way, you will apply for law of conservation of momentum in y-axis. So if you are going for y-axis, you will see one amazing outcome, that total momentum before collision in y-axis, it was 0 because none of the ball was moving in y-axis initially. No one is actually moving in the y-axis. So total momentum in y-axis initially it is 0 because uy or you can say u1y and u2y, they are actually 0. Their vertical initial components are 0. They are truly moving in the horizontal direction. So initial total momentum is 0 in y-axis, but final is not 0. Final is m1 v1 sin theta, m1 v1 sin theta minus, because it is my negative velocity, opposite direction. So minus m2 v2 sin phi, minus m2 v2 sin phi, or you can say that m1 v1 sin theta equals to m2 v2 sin phi. This relation will be helpful for further concept that there is no loss in kinetic energy for elastic collision in two dimension, which means total kinetic energy before and total kinetic energy after will be same. So if we go for that, total kinetic energy before and total kinetic energy after, now you will see one amazing outcome, that according to elastic collision condition, that total kinetic energy before collision equals to total kinetic energy after collision. So if you go for, keep one thing in your mind, that energy is a scalar quantity, so you do not need to take care of cos or sin this thing. You have to take only final velocity for this. So kinetic energy, total kinetic energy before half m1 u1 square plus half m2 u2 square, half m1 u1 square plus half m2 u2 square equals to total kinetic energy after. So this time half m1 v1 square. Please pay attention on this. Scalar quantity, energy is a scalar quantity. No need to talk about the resolution. Half m1 v1 square plus half m2 v2 square. This one. Half can be cancelled, and after that you can go for the same derivation by utilizing these two expressions. So I hope you will be able to solve these two expressions to get a condition for elastic collision in two dimension. So if we talk about coefficient of restitution, it is a simple number represented by small e, which represents that how much a body will change its relative motion, how much a body will change its relative motion during a collision. Means the original formula of coefficient of restitution is, it is a ratio of relative velocity of a body or relative velocity of a collision, we can say after collision, and relative velocity before collision of a system, before collision during any collision event. So it is a ratio of relative velocity after collision upon relative velocity before collision. This is the simplest form of coefficient of restitution or resilience. Now, if we use this formula for elastic collision, so definitely for elastic collision we have proved that for elastic collision we have proved today the first derivation of this part, this topic, that relative velocity before collision equals to relative velocity after collision. We have proved it already, that u1 minus u2 equals to v2 minus v1, or you can write this formula like this: relative velocity before that and after is v2 difference v1, which means greater minus smaller value difference sign. This is the sign for difference in physics. Now upon in a relative velocity before collision, u1 difference u2, u1 difference u2. So here for elastic collision we have proved they are same. There is no change in relative velocity before and after collision. So obviously E would be 1 clearly. These two expressions will get cancelled by each other for elastic collision. So E would be 1. So it is a very simple number. So that from this number you can tell that which if the coefficient of restitution is 1, it means the collision is a type of elastic collision. So obviously for inelastic collision E would be 0, perfect inelastic collision. For perfect inelastic collision means 100% loss in kinetic energy. So ultimately the body will not move. Any one of the body will not move. Any body. It will there will be no motion after collision. Means V2 or V1, that difference would be 0, or they will get with the same velocity. They are going with the same velocity in elastic collision. V2 and V1, they are same, just same. So if V2 and V1 by value they are same, ultimately E would be 0. So for perfect inelastic collision, E would be 0. Keep this thing in your mind. So in real life, the value of E will belong greater than 0 to less than 1. Real life, there is no perfect elastic collision or inelastic. So the E value will lie between 0 to 1. This is the range. And what about superelastic collision? So superelastic collision is actually if there is a gain in kinetic energy. And how can we gain kinetic energy without disobeying the law of conservation of energy? So we have to transform the energy form from another form of energy to kinetic energy, like explosives. In explosives or firecrackers, in explosives or firecrackers, their chemical energy turn into kinetic energy during the explosion. So definitely the value of E means after collision relative velocity will become higher than the before collision condition. It means E value will become greater than 1. So in explosives means super elastic collision. Super elastic collision. The value of E would be greater than 1. But in real life general scenarios, a E value will belong from 0 to 1.